Hello all, welcome to my channel. So today I would be covering heat engine. So in this, heat engine is covered under thermodynamics, and this is my fifth lecture on thermodynamics. So let's start with it. So heat engine is a device which converts heat energy into mechanical energy. So that means it is a very useful substance because it is converting the simplest form of energy, that is heat energy, into a mechanical energy, which is a very useful one. Now, what it consists of? It consists of three things in its system. One is source, another is working substance, the third one is sink. Now, the source is at higher temperature and the sink is at lower temperature. So the T1 is the higher temperature as compared to the sink, which is at lower temperature. Now, in every heat engine, whether it is a very complex form or is it in a very simple form, it will be working same. Now, in this case, the working substance, the working substance actually absorbs heat from the source and converts a part of it into work. As you can see, the working substance gives off some work done W. Now, and whatever be the rest or the waste amount will be sent to the sink, which is at lower temperature. Now, in this cycle of changes, the working substance return to its initial state. That means it is a reversible process. Whatever substance we have, and if it goes back to initial state, then we say it is a reversible one. Now, this same cycle is repeated time and again, and mechanical energy is obtained continuously from the heat engine. So here we get all the work done, and whatever be the waste we get at sink. So Q1 here, Q1 is here, Q2 is here. So Q1 is nothing but amount of heat absorbed by the working substance, and my Q2 is amount of heat rejected to the sink at T2 Kelvin. So this is the absorbed by whom? It will be by working substance. Q2 is the amount of heat rejected. So this is the rejected one to the sink. Rejected to the sink. And W is nothing but the net work done by the working substance. So this is what we need, basically the important part of the heat engine. Now I would be doing the derivation for sink, which will be helpful for class 11th. So let's start with it. Now first of all, let us calculate the net amount of heat absorbed in this. So the net amount of heat absorbed will be del Q. That means the change in heat. So it will be del Q equal to Q1 minus Q2. So this is my net amount of heat absorbed. Now, as you can see that the working substance returned to its initial state, as I said that it is a reversible form. So in this case, my internal energy will be 0. Whenever we consider that the system is reversible, the du in that case is 0. Now, as you know, the first law of thermodynamics. The first law of thermodynamics states that del Q is equal to del U plus del W. Now, in this case, if we put del U equals 0, it will be del Q equal del W. That means whatever be the net amount of heat absorbed is equal to external work done by the heat engine. So as you can see that del Q is equal to del W. Or you can say, as we have already written, that del Q is nothing but equal to Q1 minus Q2. So Q1 minus Q2 gives us del W. So this is the another form for heat engine. Now we need to calculate the thermal efficiency of heat engine. So thermal efficiency is nothing but the ratio of net work done per cycle by the engine to the total amount of heat absorbed per cycle by the working substance from the source. So the thermal efficiency of heat engine is given by Nita. Net work done per cycle. It is taken as per cycle, not for the whole system or not for the whole cycle. And then it's over total amount of heat absorbed per cycle. So net work done in this case, as you know, is Q1 minus Q2, and total amount of heat absorbed is Q1 only. So the neta in this case will be Q1 over Q1 minus Q2 over Q1, separating the terms. So 1 minus Q2 over Q1. So this is the thermal efficiency of heat engine. It is given by 1 minus Q2 over Q1. So this is thermal efficiency of heat engine. Now, if I say that some heat is always rejected to the sink, that is Q2 is not equal to 0. As you know that always we have some energy transferred to the sink, therefore Q2 can't be 0 anyhow. Now, therefore efficiency is always less than 1. This basically means that efficiency will be lesser than 1 always. So basically from this we can state that the thermal efficiency of a heat engine is always less than 100%. So thank you for watching this video. I will cover the second topic, that is Carnot theorem, in the next class. Thank you for watching this video.